Hi everyone, and welcome back to another lesson in Module 1. This is going to be Lesson 5, and today we're going to be talking about rate of change and slope. Our essential question today is, how does a graph's average rate of change at any given point relate to the slope? And determine rate of change and slope of lines. So I will give you a spoiler alert and tell you that slope is the rate of change. And when we have a linear equation, we have a constant rate of change. So, what is rate of change? Rate of change is the change in y, known as delta y, over the change in x, which is known as delta x. When we say change, we're doing the difference of the y values over the difference of the x values. And the symbol delta, this is a Greek symbol, a Greek lowercase letter. This is actually the uppercase, means change. So determining x and y. So x causes y, and that's because x is the independent variable, and y is the dependent variable. So y is dependent on whatever x is doing, okay? In the example, ask, does cost cause weight to change, or does weight cause cost to change? Time is always x in the element. Well, 99% of the time it's going to be. Unless you're doing something that's not natural, like a natural process, sometimes you'll see it the other way, but very rarely. Example 1, find the average rate of change for the table data. So if we look here, we're adding 3, every time we're adding 3. So my change in y is plus 3. And over here, for my cost, I think it wants you to put x. The change in x is plus 3. And here, each time, we're adding 12, as you can see. So my change in y is 12. Like I said, if you're pricing something, you're going to be pricing it based on the weight, and the cost will be dependent on the weight. Now we're going to calculate our rate of change. So rate of change is y, difference in y and difference of x. Remember, y goes in the numerator, and we end up with the rate of change being about 4 dollars per pound. Now moving on, now we're going to talk about slope. Slope is a ratio that compares the vertical and horizontal change between 2 points. So slope is often denoted as m when we're talking about linear equations and functions. So it denotes the change in y over the change in x. Like we said, we use the symbol delta, and we do y2 minus y1 over x2 minus x1. Now, these subscripts are very important because when you're determining rate of change or slope, you need to make sure that you're going in the same order for both the y and the x. So let's do an example. Find the slope of a line that passes through, and it gives you the coordinates of 2 points. So what you're going to do is you're going to label one of the points x1 and y1 and x2 and y2. Now it doesn't matter which point is which. It just matters that within the ordered pair, this is 1 and 1 and this is 2 and 2, that the subscripts are consistent when you use this formula. So let's go ahead and determine the slope, known as m. So that's going to be y2 minus y1 over x2 minus x1. So when we subtract a negative in math, that becomes addition. So 5 plus 1 is 6. And down here we have -4 minus 2 is going to be a -6, so my slope is -1. It says determine the graph's average rate of change. Well, I can see that this is a linear equation. So in this case, my rate of change is going to be constant, so I can pick any 2 points on this line, and the rate of change is going to be the same. But I usually try to pick ones that fall nicely on the quadrant so that I don't have to guess. So you can pick any 2 points. Okay, you could have also picked this point. So I'm going to determine what the ordered pairs of those points are. This one looks to be -2, 0, and this one looks to be 0, 1, 2, 3, -3. Now I'm going to determine the average rate of change. Now, when you're dealing with a non-linear function and you want to determine an average rate of change, they're going to give you a span to use, like an x value from this value to that value, because the average rate of change is going to vary based on which section of the graph you're talking about when it's not a linear graph. Okay? So, now that I've determined these 2 points, I'm going to call one of them x1 and y1, x2 and y2, and I'm going to calculate the slope. So that's going to be y2 minus y1 over x2 minus x1. That leaves me with m equals -3 over +2. So my slope is -1.5. And this is my rise, but if it's a negative, it's actually downward. And this is my run, so that means I go down 1, 2, 3, and over 1, 2. And I would end up at my next point, and that checks off to be true. And I knew my slope was going to be negative because you read math from left to right just like you read English, and I can see that my line is sloping downward. Now it says here, what is the rate of change for 6y minus 8x is equal to 18? Well, if we can obtain the form y equals mx plus b for any line, we can determine the slope by looking at what the m value is when we're in this form. So let's go ahead and obtain that form of my equation. So I'm going to add 8x to both sides because I want to isolate y. I end up with 6y is equal to 8x plus 18. They're both positive, and I want the x term to come first. I'm going to divide both sides by 6, which means I need to divide every term on the other side. And that leaves me with y equals. Now, this is a fraction. Well, it's an improper fraction, but I'm going to reduce it. I can divide the numerator and denominator by 2. That leaves me with 4/3 x plus 3. So it looks like my rate of change, or my slope, is equal to 4/3. And with slope, it's a good idea to leave it as an improper fraction instead of a decimal or a mixed number, because it's going to be most useful to you in the situation of graphing. And unless it states otherwise, it's the best option for representation. So moving on to the next part of our note. So we're looking at rate of change and slope, and like I mentioned in the beginning of the lesson, I gave you a spoiler that the average rate of change is the same as slope. So if a problem asks you to find a slope, then find the average rate of change, or vice versa. So if they ask you to find an average rate of change, then find the slope. And these two words can be interchangeable. If they ask you to find the slope, then find the average rate of change. The idea here is that the average rate of change and the slope are the same thing. So it says here, for example 5, a cell phone plan includes 30 minutes of phone calls at a fixed cost of $20, with any calls over 30 minutes incurring additional charges with a set rate. The figure shows the cost as a function of minutes being used. C is equal to F of N. What is the cost per minute after the first 30 minutes? So, as you can see here, the function remains at $20 until you hit 30 minutes, and that's when the cost goes up at a fixed rate after that point. And the rate is fixed. I can see that the line is linear, so this is a constant rate of change. Okay? So we want to determine what that rate of change is so that we can write a function. So how we're going to do that is we're going to find the coordinates of some of these points. So let's start here and find the coordinates. Well, my x value is 30 and my y value is 20. Now I'm going to also find the rate of change, the coordinates for one of the points up here. I'm going to choose this one because it falls neatly on the Cartesian coordinates. So this is going to be 50 and this is going to be 70. So now I can determine my rate of change or slope by using the formula m equals change in y over change in x. I'm going to call this x1 and y1. I'm going to call this x2 and y2. And I'm going to plug in and evaluate. So I have y2 minus y1 over x2 minus x1, and that's going to be equal to 50 over 20, which reduces if I divide the numerator and denominator by 10. That's going to reduce to 5/2, also known as 2.5, and that's my m. So what is the cost per minute after the first 30 minutes? Well, we can write a function that represents that, and m is the variable here instead of x, so the function is going to be f of m is equal to, now I know that the $20 is the fixed cost, and we're going to call this our y-intercept. Okay, that's a fixed cost. So remember, we don't incur any fees additionally until our x value is over 30. Never mind, we're not going to do a function. I'm getting ahead of myself. That's going to be an upcoming lesson because this is technically a piecewise function, which we'll talk about in the future. You can totally come up with an equation for this, but yeah, we're not going to do that today. It's a little more complicated. All they want to know is what is the cost per minute after the first 30 minutes, and we know that's 5/2. And if we write that in terms of money, we divide 2 into 5, that's going to be $2.50 per additional minute after 30 minutes. So yeah, that's all I have for you today. Sorry about that. Sometimes I get carried away and try to go too far, but we're not there yet, so don't worry about that. Anyways, have a good rest of your day, and I'll talk to you guys soon. Let me know if you have any questions. You know how to reach out. And